Hello, my name is Matthew Erickson. I'm here with the final project for GAM470. We will jump right in with showing off the project here. Mine was a simple desert world that was inspired by a D&D campaign a friend of mine is running that we're playing in. We were kind of crash landed on a desert planet, and there's a lot of different elements from it in here. So first of all, we can see that there's a sun. I know I've shown this effect off in one of my other projects, but while you get closer to this, there's actually just point lights around the sun that give it the yellow look, and then the white that you can see is now shrinking is just a spotlight that's set on the player and constantly looks at the sun. So, you know, it gives it that sun look, which is really cool. This ship here, which we can see, hey, look, the light bounces off of it. Cool. Is supposed to be like our escape pod. The lighting effect here is supposed to be coming from the engines. There's two lights that are right around here somewhere that point at each of the engines, and then there's one actually on the engines that point back here and give us that lighting effect. The other enemy fighter, who is supposed to be searching for us in the scene, is flying around in a circle with a light down. We saw that it bounced off of that ship before. You can see the lighting effect over here. That's a directional light. I've got one for both the color and texture ones. It kind of looks like it's coming from the sun. That's why the sun got put over in that corner instead of like straight up in the sky. There is a plane over here. And by plane, I mean a flat plane, not an aeroplane. I don't know why I said it like that, but, you know, this is supposed to be like a cave entrance where some monsters live. It's not great, but it showed off what I needed to show off with that. You can see the light bounces off the house there. One of my more favorite things is this particle effect. Looks like the smoke got adjusted up a little bit, but you can see that there's two different particle effects happening here. One's got the color pyramid, and it's supposed to be looking like sparks. That's why it's a lot more intermittent, where the other one is supposed to be smoke, and that's why it ends up looking a lot more continuous, natural, also going straight up in the air, whereas the other one is kind of shooting out to the side, you see. And it's supposed to have been, this thing was attacked by the monsters that live in the cave over there. Other than that, you know, the slash one is a texture map, or like a cube map is what I meant to say. Made it up just so I could show that one off. This is the 6-face cube that I scaled, and as you can see, there's a lighting effect on here, which is actually coming from that ship over there, which is a bit of a screw up, but it works. And I wanted to show off all the different pieces. This is the repeating face, what is it? The pyramid, that's the word I'm looking for. Sorry. That's got, it's supposed to look like kind of like a drill. This is supposed to be a mining machine, and then this truck that comes is supposed to be the thing that's picking it up. I was super surprised at how hard it is to find a semi-truck model online. And I found this one, which unfortunately the textures weren't set up right. I don't know why, but it ended up being 3 different models, so I wanted to use it because of that. Or 3 different meshes, not models, sorry. There's 3 different meshes in the one model, so I ended up just making 2 of the models gray, and with, you know, just a gray texture, and then the other one green. You can see the 2 different ones, and then there's like a wheel in between there. That's the 3rd model. You can't even really see it, so but you know, that allows for that. Looking at the height map texture, or height map terrain, I should say. I just found a terrain editor online to use with that. This sand texture ended up being it just looks amazing. I can't understand. It amazes me how well this came out. And it's just, your simple terrain. There's a fog effect, which is the only thing that's affecting the skybox right now. Lights don't affect it, but but fog does. Show off how that works in a bit. And then, as you can see, everything is affected by the fog as it gets farther away. And if we go extremely far away, like outside of the world, far away, even, things start to get completely blurred out. See how long it takes us to get it. See, we're completely outside of the skybox right now, and this is something that, if it was an actual game, we had collision detection and stuff like that, I would cancel out. But as you can see, things get faded out as they go away. As we come back in here, is there anything else I need to really show off right now? Ooh, you can see the truck light up there. I don't think so. We can just get into the code now. I'll just close that out. Yay, no errors. No errors, no leftover things in here, so we're all good. Texture. This is the second time I'm recording this video, so I have to close down a bunch of things and start from the beginning of where I was. Should have done this before I started recording. Let's just start with, I think the models and skyboxes are first on our checklist. Everything except for the skybox is affected by lighting. Yeah, that's just what I was saying. Everything except for the skybox is affected by lighting. There are 2 directional lights in the scene, like I was saying, one for the textures and one for the color ones. I think the only thing affected by the actual colors would be the particle effects, and most of them are drowned out anyways. But at multiple point lights, I have at least 6 point lights around the sun, but I figured that was kind of a little cheat. So I didn't really count those as my 3+. There's actually multiple spotlights, like I was saying, there on the engines that are coming off of the ship that's flying around. That's 5 I can think of right there off the top of my head. There's one that affects the color ones. So there is a lot of different lights in the system, or in the thing. And we saw the one moving. And it moves over objects that are moving or objects that are not. As in the connection between the enemy ship and the truck, or the enemy ship and any other model that's not moving. Also the particle systems move through light. So, that's what I was just saying here. The truck was moving and the particle systems are moving through the light to actually give them that spark look where, they're like bright at first and then they kind of die out, which was really nice. And then you saw the fog. I showed that off a decent amount. All right. So I put all the pre-made objects in here. Let's get to my models, which are just made, in the code here. This is the CPP. Why am I too tired to do things? Oh, okay, this is the just normal creation of a model. What is going on here? Oh, if it would help if I scroll all the way to the top of the file. That's what makes sense. Okay, so the model, you can either make it just by giving it, the list of triangles and list of vertexes if you want, or, load one from a model or from a file, or load one of the standard ones that are in here. I end up using all of these. I use the sphere for the sun, the repeat texture for the drill, the pyramid for for the spark particle effect. The 6 face was the cube on top of the drill that got slashed. The repeat texture was the actual machine, and then the create unit box, or the unit box was the smoke particle effect. So all of those are used. You can have multiple meshes. Let's see what we actually should be talking about here. Necessary mechanics to render the model as a whole or only specified meshes. So yeah, I have it set up so you can have, your specified meshes. Valid mesh number, get mesh count, different things like that. Here we are, the render mesh. So you could render each individual mesh if you want, or you just pass in the number. I don't think I actually use that in my scene. The one that has the multiple meshes, I just have it do a for loop where it renders all of them. Looking here at the graphic object, yeah, I've just got the for loop that ends up just draw them all. I could see why it would be useful, but I just didn't have any use for it in mine. So, it just worked out better just to have this. But, if you remove this for loop, you could do what you wanted to do with it, and render just one if you wanted. Going back to my checklist here, skybox. So with the skybox and the terrain, I did it a little bit different than how it was stated here. Instead of making their own graphic object class sort of idea, I just went about it doing where I just added this function right here where you can just get the model from it. So the skybox just stores the model, and then just passes it into a graphic object, which I can show how I do that right here. Scroll up to the top. With the terrain one, I just pass in the model to a graphic object, or the skybox, I do it the same way, and then you can just use that graphic object. It just didn't seem like it was worth it to create another one just for those two. Speaking, all of the systems work the same way. It just seemed like the better way to do it was just make it so you could pass them into a graphic object that's already there, instead of trying to, redo all of those systems. It just seemed like it was more code efficient to just do it this way. I guess one might call it laziness, but it wasn't a matter of laziness on my part. I look at it as just there's no need to rewrite the code reuse, whatever you want to call it, Yeah, so going back to my checklist. Oh yeah, so the terrain works the same way too. The skybox just, actually I should, when you create the skybox, it's just, a length, so it'll build it to size. Let me pull that back up quick. So it just builds it out to size. Pretty simple. The numbers here are really big. I could have made them smaller, but when I was messing with the skybox originally back in whatever assignment that was, I had a lot of problems with lining up points on the edges. So in order to be pixel perfect on these, I just made it so that, this number is the size of the width and this is the height, and then just, divide by there and get the numbers that you need. Might be a little less efficient because of the fact that there's division going on there, but it's a little bit more user friendly to look at it this way. So I decided to go with that direction. Whether it's the right way or the wrong way is up for debate, I guess. It probably would have been better to do it the other way, but it didn't seem like a big deal to me. Now, if you were to get into like multiple skyboxes and stuff and you were redrawing it or something, then maybe I could see it being, but it's only ever done once, so the couple divisions aren't really that big. I don't think they're that big of a deal to look into. The shader classes and the HLSL. A lot of my shaders are, the same. Well, not the same, but they're very similar to each other. They all pass in different buffers: the fog buffer, the color buffer, light buffer, all the different things that need to be passed in. Set the different things, light parameters and stuff like that. Sorry. So the fog is one of these things that's interesting to look into. I think I ended up, when I was looking at this before, I think I set the default in like 3 or 4 different places just to make sure that it has a default, because I know that was something that was stressed. So yeah, here's another default, and here's a default. But the default that ends up getting called is, I use these infinities because it's just a large number, which allows it to, it's just a really large number, which means that you have to get extremely far away if you're not setting the fog in order to actually trigger them. And if you're that far away, you're probably going to be causing other problems with your programs, like integer, like rounding, or not rounding, overflow is the word I'm looking for. And if your scene's that big, you must have a really powerful computer to run it, or you're far enough away from your scene where it's going to be like 1 pixel big on the screen. So if it's that much, you would also have to have the camera like view distance like as high as you can go, and you'd run into a lot of other problems before you actually started seeing the fog, is the point. So looking at the HLSL for these, we'll take a look at this one first. This is the one for no lights on a textured object, but it does have the fog added into it, and that just, I don't remember if the world inverse was here or not before, but I definitely had to add this eye position world, and the I think I added the world inverse. I don't remember though. And then I had to add the other buffer here too for the stuff. And then just down here, instead of just passing through the texture.sample here, we just had to do a little extra work to it, and then return stuff. I just used the lit color because that was what was used in the other ones. There is no light on this one. It's the sky. I think the skybox uses this one in my scene right now, and I believe that's the only one that uses it. So that's what's going on with that one. And then looking at the multi-light one, this one, I did a lot of looking around, and I really, really wanted to get it so that you could pass in any number of lights. But from everything I found online, there's not a great way to do it. I'm sure there's a way to do it, but not a great way to do it. So because you can't dynamically set the size of arrays, you have to use a specific number. They don't allow you to use a variable here. And I don't know if that has something to do with just hardware limitations, or if it was just something that whoever created HLSL set up didn't get that far into researching it. But so I just set it up so you can have 8 point lights and 8 spotlights. And then down at the bottom, it just runs a for loop through all of them. to add them all up. And I did the same thing in the color light. There it is. 8 of each. And I think I was talking before about the spotlights and point lights that I use, but there's a bunch of them in the scene. So those are the different HLSLs. Kind of went over the shaders too. Spherical fog, went over fog, went over, oh yeah, the illumination. We're using the fog illumination. Many different point lights and spotlights. Okay. Graphic objects. Let's go back to the code here. So there's a base graphic object, which really all it does is store a model, because every graphic object needs a model. So, that's the first place to start. And then if we get into some of them, let's open them up here. It stores all the information that you might need, the fog vertexes, the fog information. That's the word I was looking for. Sorry about that. The matrix of, the rotation, the the position of it anyways. Translation is the word I was looking for. And the scale, which, the scale throws things off, but okay. And then, the different lighting effects, the texture and the shader that you need. And then the model comes from the base. But inside here, it's got the sending of fog either based on the mesh number or just as many as you want. Once again, I've got the infinities and then that midnight blue for a color here. And these, I believe, are called, is it here or is it somewhere else? But I need the CPP file for this. I haven't opened it yet. Oh yeah, I did, but okay. So at the beginning, we set it again with the fog colors with the infinity, and then I chose white up here. Probably should have been a little bit more consistent on what I was using for that, but it's okay. And then down here, yeah, we send the fog regardless of if it's been quote unquote set or not, because it has been set, because there's really the only one constructor here, and it makes sure to set the fog. So, and the lights are set, or material, not the lights, but the material that will be affected by the lights is set there too. So everything's set up, and you can't have, you can have no fog show up in your screen, but technically the fog is still there behind the scenes. It's just not ever being drawn, because if you say you don't need it, then you don't need it. So, and that's the default. So, let's see. Render method automatically requires shader. Yep. That's all done here in the render. Sets the model and shader to context, sends all the information that needs to be sent, and then tells it to render. What else do you need? Constructor. Yep, we got that. Receives the shader in the model, puts all the information in that it needs, sets the world to identity to start. Various setters. Yeah, and then the setters, you can do it on a per mesh basis or just do it to all the meshes. This one, so basically if you don't specify a mesh number in the beginning, it'll just do it to all of them. Whereas if you specify a mesh number, it'll do it properly. So looking at this mirror, yeah, I did assignment 8. That was already done, but I don't have a mirror in my scene, so that's fine. We don't need to go into that. Let's take a look at the, I don't remember if I explained the particle system or not. Might have done that last time I recorded. So, looking at the particle system, it's a very simple model of a particle system. There's definitely, it's not 100% the correct way to do this, but it was a way that worked and worked pretty well for what I would say, for how simplistic it is and how, you know, I didn't put a huge amount of time into it, just enough to make it look good. And overall, I think it came out looking really good, actually. I was pretty happy with it. But when we set up the particle systems, looking at them, here they are, the one for the spark. You pass in, you know, the device, or you pass in the model that you want to use for it, and then an array of colors, which that's just what these are doing here, is just setting up an array of colors. So in the particle system, you have to give it a model, a position that it's going to start from. This is where like the emitter's at, not necessarily where anything else is at. Ooh, that's why somehow that got changed to 0 on the smoke one. Then we've got the shader lights. Oh yeah, that's the shader. Sorry. The part colors then are this part colors that we see in here. Right here is the array that's coming from here. Because I used white here. Okay, and then this is just another way of doing an array of vectors, and all it's doing is passing in one with white, and then our specular vector that we've been using. The reason I have them pass in an array is for like the smoke one. You can pass in multiple different colors, and it'll kind of make them different. It'll randomly choose a color and make that color, which worked out really well for the fog, or not the fog, the smoke, and gave it a really smoky look because I was able to go anywhere between light gray and black, and just made it look a lot more like smoke. I thought it came out really good. Then what else do you have to put in here? The number of colors is the number of the max amount of particles you can have on the screen is 50 for this one. And then we get into this is the 10 is the average x like direction, so it'll be pointing at like x equals 10 on average, or sorry, x equals 0. The 0 is the average. The 10 is the variance, so it can, you know, move up to 10 from 0 in either direction. So, and then the next one is the same thing for the y, and then the same thing for the z, the average, and then the variance of how far it can go. Then how much gravity affects it. So, you know, you can change this number to make them go higher or fall faster or whatever you need to do, and then how long they live, which is the 20. And then there's two other ones on here that were for the other vectors, the number, but they're set to 1 normally, so I didn't add them into this one. Whereas the smoke does use them, and it's got, you know, 100 pixels on the screen, or particles on the screen. You can see there's no gravity on the smoke particles, so they'll just keep going up, because that's kind of what smoke does. Then how long they live is a lot longer than the other one, and then the color numbs. And down here, we can show off how they work a little bit. Whereas the spark one just kind of makes everything and then stops making it until there's not a, you know, the max amount of particles on the screen. Which gives it that burst effect where it kind of just makes a whole bunch and shoots them out there, and then waits, and then makes a whole bunch and shoots them out there. Whereas the smoke one, there's a little bit more time in between. So there's like 100 frames in between each create. So it more makes them on a more continuous basis and gives it that more continuous look to it. Then we get looking at the particle system, how this is done. So it sets up everything. Oh yeah, so that's what I wanted to look at. When it's actually spawning particles, so it'll actually go through and it'll only do things to ones that are alive. So this is kind of like a, it only does, things are marked as alive or not. And it can only spawn particles that are not alive. So kind of like a hacky, quick use of object pooling. So it'll create all 100 in the particles up here in the create, or the constructor right here. It creates all the particles, but you know, they're not alive yet. They're dead. They're not going to do anything. And then down here, it just goes until it finds the first dead one that it can find, and then just updates the value on that. And then later on, when they die, which is in the actual particle, it just basically turns them off and leaves them there until it needs to create it again. Sorry about that. Then we got, you know, the move particles, which just moves them and calls this die function, which basically just, we'll get to it in a second here, but it basically just looks at it removes an X amount of time from its life total, and if its life becomes 0, it dies. And then render just renders all the particles that are alive. You can see in all of these, it only checks the ones that are alive or dead. In this case, it only does stuff that are dead. Also, this K value makes sure, like, it counts up every time we count a particle, and that way, you know, if we're not going back and checking particles that we've already checked, because this wants to spawn X amount of particles. So, but you don't want it, like, you know, if the first particle that you make is number 13, you don't want to go back and check those other 13 already that you've already checked. So that's where this is counting up, and, you know, J gets set to K, so it's already checked those 13, so it'll start from probably 13 again, but it might be it'd be 14 because we're adding right before we do stuff. So all right, then onto the particle system, or onto the particles themselves. You can see in the default one, you know, it sets their alive to false, and basically they're just dead and somewhere. There's the isAlive function, the move function. The move function, all it does is moves it from the direction. So it looks at the direction that it has, that it vector that it built, times that by 0.1, which is kind of just like a move speed limiter sort of thing, and then adds that onto position, and then sets the world matrix equal to the trans of the position, and then the direction, we subtract gravity from the Y to kind of, you know, have that slowing effect happening. The die one, like I said before, it just life and removes time from the life. If the life is less than or equal to 0, kill it and set the life to 0, just in case it's negative. That way you can, you know, just average it, you just default it out to 0. And then this just calls the render on the graphic object that's being stored in here. Yeah, you can see there's just a couple of things there that are stored in the actual particle. All right, I am losing my voice from this. So, taking a quick look just then overall at the DirectX app, you can see that most everything is done in the init demo now. Barely anything is done outside of that, and that's really only for things that move, like the enemy ship here, the light under the enemy ship, the cargo truck moving, the particle systems, the camera is most of this. And then, you know, there's a couple of things in the draw that need to be set up. the camera position needs to be passed to a million different things. This one light needs the camera position sort of thing. So, it's got to get all of this information, all these different lights and shaders and whatever else needs it. And then it can just call render on everything and it's done. That's all it needs to do. And then we just got to make sure that we delete everything that we've called. And doing all that, we can, run it again. And as you can see, this will take a couple minutes. I think it's got to build again because I changed that one value. But you'll see here that when the game loads up, there's the white screen here that we're seeing. That'll be up there for a while. But after it gets through that, it's done. There's no more loading it needs to do. Everything's loaded before that. And we get our scene that we can then run around and go different places, taking a look at the particle effect. You can see that the smoke has different colors, anything from light gray to dark gray to black, whereas the sparks are just kind of yellow. And they, I've got this spotlight here that shines down on it. It makes everything white from that angle, which was a bit annoying, but it works out. The truck lights up. But yeah, this is my project for the final of 470. I had a lot of fun doing this. I really like how it turned out. There's a couple of things that it's like, well, yeah, I'd probably do that a different way if I wasn't trying to specifically show off something. Sorry, I'm losing my voice. But, overall, it worked out pretty good. Still amazed at how hard it is to find a decent semi-truck online for free, but, spaceships are really easy to find. That's a good thing. But that's all I have